When we make molecular orbitals from atomic orbitals, we take the atomic orbital wave functions and use linear combinations. We add and subtract them with constant coefficients to make molecular orbitals. In this case, for molecules that we're forming from atoms with 1s atomic orbitals, like hydrogen and helium, we bring the 1s together and form a sigma bonding orbital and a sigma antibonding orbital. Two atomic orbitals to form two molecular orbitals. Now for the case of helium, the 1s orbitals have 2 electrons. So a helium molecule has 4 total electrons, and they need to occupy the molecular orbitals. So I'll take those 4 electrons from the atomic orbitals and populate the molecular orbitals, and I'll use my usual electron rules. I'll fill parallel and antiparallel and parallel and antiparallel in the higher energy orbital, and I find that both the bonding and antibonding orbital for this molecule are completely full. Now, the bonding orbital is favorable for bonding. The antibonding orbital is unfavorable for bonding. A lower energy interaction and a higher energy interaction. So those two cancel each other out. Helium, He2, the molecule, doesn't form because it's not favored by the molecular orbital system. You can continue, though, and look at lithium. If I go across the periodic table, let's look at lithium. Now I'm looking at a 2s electron. A 2s electron, I can take the 2s orbitals and use this same procedure. Add and subtract them to take a linear combination, form a sigma 2s and a sigma 2s star antibonding orbital. Those molecular orbitals are filled with the electrons from lithium. Lithium has 1 electron in its 2s orbital, so 2 lithiums, 2 electrons. They fill up the bonding orbital for the lithium molecule. Li2 we would predict to be a stable molecule. It has a bond order of 1. Now the bond order we'll define as the sum of the bonding electrons minus the antibonding electrons. So when we look at beryllium, Be2, beryllium has 2 electrons in its 2s orbital. So I have to take for beryllium 4 total electrons. Be2 has 4 electrons. I'll put 2 electrons in the bonding of sigma and the 2 electrons in the antibonding sigma star orbital. I'll calculate the bond order, 2 electrons here for bonding minus 2 antibonding electrons. The bond order is 0. So Be2, the beryllium-2 molecule, doesn't form. So my molecular orbital theory has predictive power, and it can predict the bond order and whether or not bonds form in molecules.